Yeah, this easy learning Maths 112 tutorial class. We are still in indices. Our topic today is indices law of indices. We are in the indices equation. Indices equation. Lesson 3. We're in lesson 3. If for you to understand it proper, I have to learn through lesson 1 and lesson 2 before you get to this. For you to understand us properly here. So indices equation, that's where we are. Indices equation. Then now, you remember the indices equation stated that if we can make the both sides of the equation to have the same base, automatically their power is equal. Just like when we have 2 raised to power x, 2x is equals to 16. They say find x. Here, this is indices equation as we said in the lesson 2. And this indices equation have 2 laws. The first law is what we are battling with. He said, if we can make the both sides of the equation to have the same base, automatically their power is equal. If we can make the both sides of the equation to have the same base, automatically their power is equal. We look at this. 2 raised to power 2x equals to 16. And this is 2 raised to power 2x is equals to 2 raised to power 4. We give me 16. Look at it. 2 raised to power 4 is the same thing as 2 times 2 times 2 times 2. And this is 2 times 2, 4 times 2, 8 times 2, 16. By so doing, I have not altered this. So making both sides to have the same base does not mean that you are going to alter the equation given to you. Making this to have the same base, I still have 16. So right now, I've made this to have the same base. Automatically, I will say 2x is equals to what? 4. And therefore, x is equals to 4 divided by 2. And the x is equals to 2. Then someone will say, what if we can't be able to make them to have the same base? What if we don't be able to make it to have the same base? What are we going to do? If we cannot make them to have the same base, we take log of both sides. We take log of both sides. If you cannot make them to have the same base, we take log of both sides. Natural log of both sides, which is log base 10. Example, if you have 2 raised to power 2x equals to 3, there's no way I can make these things to have the same base. There's nothing I can, let's say I have 2, but base 2 raised to power what will give me 6? It's not possible. Base 2 raised to power what will give me 3? It's not possible. Therefore, I take the log of both sides by saying log 2 raised to power 2x base 10 equals to log 3 base what? 10. And this is something as 2x log 2 base 10 equals to log 3 base 10. Then making this subject of formula, this will be 2x equals to log 3 base 10 all over log 2 base 10. And log 3, in your calculator, we have log 3 giving me 0.4771 all over log 2. I have log 2 equals to, that gives me 0.3010, and this will be giving me 0.4771 divided by 0.3010, that gives me equals to 1.5850. And now I have that 2x is equals to 1.5850. Therefore, x, you remember, to make x subject of formula, I have to divide through by 2. I will have 1.5850 divided by 2. Making this subject of formula, I have to divide 2 by 2. When I divide this by 2, means 2x divided by 2. This will kill, leaving me with x. Divided by 2, I have this. Therefore, I have x is equals to, divide by 2, giving me 0.7925. X approximately, this is a 4-figure table, this is 4 decimal points. In 2 decimal points, in 1 decimal point I have 0.8. This is in 1 decimal point. In 2 decimal points I'm going to have 0.79. That's in 2 decimal points. I'm leaving this in 2 decimal points. Then in 3 decimal points, this will be 0.793. I think you get it. In 1 decimal point, this will be approximated. This is up to 5. Immediately this is up to 5. I have to approximate it to the 1. I add it here because it's. For 2 decimal point, this is 1, 2. This one is not up to 5. Therefore, I will round it up to the what? 0. I add it to 9, which gives me 9. Then to 3 decimal point, which is 1, 2, 3. This man is up to 5. I'm going to round it to 1 to give it to this to give me 3. So you see, rounding it to 2 decimal points, I have this. Rounding it to 1 decimal point, I have this. Rounding it to 3 decimal points, I have this. By so doing, we have learned how to round up to decimal points. Then now, let us go to what? Indices equation that lead to quadratic equation. Before then, let's look at the second law of indices equation. Second law of indices equation. Second law of indices equation. He said, if we can make the both sides of the equation to have the same power, right? Looking at this, for instance, looking at this, we solve now. This, what we are looking for is power. We are looking for power. They asked us to find x, which we are looking for power. This man said, if we are looking for power, if we can make them to have the same base, the power will be equal. And that's what we did now. Since I'm looking for power, I have to make them to have the same base. And the power I'm looking for was equal. Then here, in this second law, it said, if we can make them to have the same base, that means I'm looking for base. If I can make them to have the same power, that means I'm looking for base. Automatically, their base is equal. If I can make the 2 sides of the equation to have the same power, automatically their base is equal. If I have x raised to the power 3 is equals to 27, they said find I should find x. To do this, I'm going to do this by saying x raised to the power 3 is equals to 27, and this x raised to the power 3 is equals to 3 raised to the power 3 will give me 27. 3 raised to the power 3 give me 27. I've made them to have the same power, power 3, automatically I will say that x is equals to what? 3. You see? If we can make it to have the same power, automatically their base is equal. That's the second law of indices equation. The first law said if we can make them to have the same base, automatically their power is equal. And that's what we use here. If I can make it to have the same base, automatically the power is equal. Have you seen it? Then if I can make it here to have the same power, automatically their base is equal. This is the 2 law of indices equation. The first one is what we have dealt in our lesson 2, even bringing it to lesson 3. Then in here, we are dealing, if we can make them to have the same power, automatically their base is equal. Let us look at another example here. I have here y is raised to power 3 equals to what? 8. Find y. I cannot say that what? That y raised to power 3 is equals to 2 raised to power 3 give me 8. 2 raised to power 3 will give me 8. Therefore, I cannot say that y is equals to 2. Then, there is general formula to solve this. The general formula to solve this, if you won't be able to remember this, you can use log of both sides. You can use what? Log of both sides to get this. If this is given to me, I can remember these two law of indices equation. I can take log of both sides and I'll get the answer of this. I can take the log of both sides and I'll still get the answer of this. Therefore, if you take log of both sides, you'll be able to achieve this. For instance, look at this that is given to me. Let us clean this. Let us work this and look at. Know that you can take log of both sides and you'll get the same thing. If I have now, for instance, I have 2 raised to power x equals to what? 8. They say find what? X. I can solve it by saying, making them to have the same base. This is base 2. Then what will I raise 2 to? What will I raise 2 to? That will give me 8. I will raise it to 10. It will give me 8. This is base 2. What will I raise 2 to? That will give me 8. I will raise it to 10. Give me 8. Therefore, x is equals to what? 3. Or I can take log of both sides by saying log of what? 2 raised to power x base 10 equals to log of what? 8 base what? 10. I cannot say that this is x log 2 base 10 equals to log 8 base 10. And I can say that x is equals to log of what? 8 base 10 divided by log of 2 base 10. And the log of 8, log of 8, in our calculator, log of 8, I have log of 8. Let us try the log of 8. Log of 8 can give me, this can give me log of 2 raised to power 3 all over log 2 base 10 base 10. I can use this to say is equals to 3 log 2 base 10 all over log 2 base 10. And this, we kill this. I'll have that x is equals to what? 3. Log of 8, this is 2 raised to power 3 will give me 8. This give me 3 log 2 base 10. Log 2 base 10 will kill, I'll have what? 3. And that is the answer. Using the log of both sides, we'll still get the same answer. Then let us look at this question. 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 It says solve for x in 3 raised to power 2x minus 3 raised to power x plus 1 plus 2 equals to 0. We say solve for x in this equation. 3 raised to power 2x minus 3 raised to power x plus 1 plus 2 equals to 0. And so we should get the x. This is indices equation that will lead us to quadratic equation. This is indices equation that will lead us to quadratic equation in solving. And that's the reason why we learned that indices law. For us to solve this as a solution, I have 3 raised to power 2x minus 3 raised to power x plus 1 plus 2 equals to 0. You remember that this can be written as 3 raised to power 2x minus 3 raised to power x times 3 raised to power 1 plus 2 equals to 0. You remember? You remember the law that says a raised to power n plus what? M. is equals to a raised to power n times what? A raised to power m. So this man can be written this way, which you have learned. Then, again, after I have done this, because of this man, I see this man here, which is 3 raised to power x. That implies that I'm going to have 3 raised to power x here. As I see 3 raised to power x here at the middle here, it implies that I'm going to what? Get 3 raised to power x here. And what am I going to do? I'm going to use the law, power law, by saying that this man is something as 3 raised to power what? X, all raised to power what? 2, minus. This gives me 3 raised to power what? X, times what? 3 raised to power 1, plus what? 2, equals to 0. Why? I said, because I have 3 raised to power x here, that implies that I'm going to have what? 3 raised to power at the 3 raised to power x at this first term. Because I have 3 raised to power x here at the middle, remember, that implies that I'm going to have 3 raised to power x here. And for me to have 3 raised to power x here, I employ the law, the power law. What's the power law? We say that a raised to power n or raised to power m can be written as a raised to power m or raised to power what? N. This is the power law. We say that what? A raised to power n or raised to power m can be written as what? A raised to power what? M or raised to power n. Looking at this 3 raised to power 2x, which you said, is same thing as what? 3 raised to power x or raised to power what? 2. And which give me 3 raised to power what? X times what? 2. Which give me back this, which we have learned. Then therefore, I go back to this. Since, why did I do this? Somebody will ask me. Why did I do this? I did this because I saw 3 raised to power x here. I did this because I saw 3 raised to power x here. As far as I saw 3 raised to power x here, it implies to me that I'm going to have 3 raised to power x here. By the time I have 3 raised to power x here, I'll simplify this by saying let's 3 raised to power x be equals to what? P. Meaning, let 3 raised to power x to be what? P. I have now equated this 3 raised to power x to be P for me. Why am I doing this? To make this equation to be simple for me to solve. With this, I can continue with this to be able to solve them. It will be cumbersome. By putting this, I'm going to make this equation to be what? Simpler. Then I will have here P raised to power 2. If I remove this, I put P. It will give me P raised to power 2 minus. If I remove this, I will have what? P times 3 raised to power 1 plus what? 2 equals to what? 0. Then by solving, I will have P raised to power 2 minus 3P plus what? 2 equals to what? 0. How did I get it? 3 raised to power 1 is 3. 3 times P will give me 3P. And the minus remain there waiting for us. Then what next? I have formed quadratic equation. We have said that this equation have lead us toward quadratic equation. And that's what I said earlier. This is synthesis equation that leads to quadratic equation. Then how did I do this? I have to factorize. How do we solve quadratic equation? Either by factorization method or by eliminating, either by factorization method or by completing square method or by formula method. These are 3 ways we solve quadratic equation. But let us learn factorization by factorization method. For me to factorize this by factorization method. How did I factorize? First thing I'm going to do is to say what? P squared times what? Plus 2. P squared times plus 2. This is a plus 2. Will give me what? 2P squared. For me to factorize, I'll fix it. P squared times what? Plus 2. This is a plus 2. Will give me what? 2P squared. The next thing, I'll ask myself, that's the range. I have gotten my range. I'll ask myself, what's 2 terms that I will multiply together that will give me this? And the same that 2 terms, when I added them together, it will give me minus 3p. I'm coming again. After I have done this, I'll ask myself, what 2 terms, the 2 terms that I can multiply together, that will give me 2p squared. The same that 2 terms, when I add them together, it will give me minus 3p. And that 2 terms should be minus p times minus 2p will give me 2p squared. Minus times minus will give me what? Plus 2p. Then minus p plus minus 2p, that gives me minus p minus 2p, and the answer will be minus 3p. The answer gives me minus 3p. And since the answer gives me minus 3p, it means that I can use this to replace this man in the equation. It means that I can use this to replace this man in this equation. So what I'm looking for whenever I'm factorizing is the factor that I'll use to replace the middle term. This is the first term, this is the middle term, this is the last term. The factor, the value I will use to replace the middle term, that's what I'm looking. That's what leads me to factorization. And get what I'm saying? That's what leads me to factorization. Then now, doing that, this my equation will turn to be, the equation to turn to be this. The equation will turn to be this, square minus p minus 2p plus what? 2, and is equals to 0. That's what equation is going to be. This equation now turned to be 4. 1, 2, 3, 4. Before, it is 3. 1, 2, 3. 3 times. And this 3 times, I can't be able to share it into 2. Because if I can't be able to share it into 2, I have to factorize. To factorize is to get 2 terms that I can use to replace this minus 3p. And that 2 times is minus p minus 2p. I have used it to replace it. Are you getting what I'm saying? Then now, when I have done that, I have to have this minus what p. I'm putting it in brackets. I can share it now. Here become minus. And when I did this, the first bracket, the sign that is here will be the sign in the second bracket. I'm going to have this 2p minus 2 in bracket, and it's equals to 0. Somebody will say how? Somebody will say how? I said, if I have the sign negative at the first bracket, the second bracket will have negative. I said, if I have negative at the first bracket, the second bracket must have what? Negative. The first bracket, I have now to share it into 2. There are 4 in the back. I have to share it. The first bracket, this is a minus. This must be minus. If, look at it, minus times this will give me minus 2p. Minus times this will give me plus 2, which go back to the 4p equation and simplify it. But if I put plus here, assuming that plus is here, this equation will be altered. Looking at this, minus times 2p will give me minus 2p. Minus times plus 2 will give me minus 2, which is not in the equation. I'm sorry. Therefore, what will be here will be what? Minus what? 2. So, in generally, I said, when I have negative sign here, in the first bracket, the negative sign will be in the second bracket. If I have positive sign in the first bracket, the second bracket will be what? Positive sign. I think you noted it. If I have negative sign here for the first bracket, the second bracket must be what? Negative sign. Understood? Then we'll go back. And I come back here to say, what is common here? I can divide this by p, which give me p. I can divide this by p, which leave me with 1. That means p is common here to here. Then into this, I'll have minus. What is common here? I can divide this by 2, which give me 2 out is common. I'll have p. And 2 divided 2 will give me 1. And that will give me equals to 0. So, how did I do this? I look at what is common. P is here, P is here. I can bring it out. And when I bring 1p here, I'll leave with 1p. When I leave this p, it will drop 1. Then 2 is common here. When I bring these 2 out, I'll have p. When I bring these 2 out, it will drop 1. How is it dropping 1? You remember that anything we write is multiplied by 1. If I have this y, it stands by 1. So if this y is leaving, it will drop 1. So what I'm having here is 1. And here, what is common here? And I will do what? P minus 2. in bracket, and I will do p minus 1 and all equals to 0. Looking at it, you see that this minus 2 is first bracket. These are common. I take 1 and I multiply them together. If I expand this, I will get back this. If I expand this, I will get back to this. And this is where we arrive. Looking at it again, I said p minus 2 in one bracket. I take any of the bracket and multiply it is equals to 0. Then again, for these two things to multiply themselves and answer is 0, you know what it means? That this man jam this man and answer is 0. This bracket jam this man and the answer is 0. For two things to multiply themselves and answer becomes 0, mean that any of them, one of them must be 0. Either this man is 0 or this man is 0. Just for instance, two persons is living in the house and something is missing in the house. And these two persons is only people that have access to the house. And something is missing in the house, in that house. It's no doubt that either one of them took that thing that is what missing in the house. It's no doubt. So for these two persons to jump themselves and answer is 0, it means that either this man is 0 or this man is 0. Because anything turns by 0 is equals to 0. If I multiply 0 by 2, the answer is 0. Just what I said, 0 times x, the answer is what? 0. 0 times y, the answer is 0. So for me to have an answer to be 0, means that 0 multiplies something. For me to have answer to be 0, so this time this to have to be giving the answer to be 0 means that 0 multiply any of them. That means I said you are the 0. That means p minus 2, this bracket is 0. Which 0 times this gives me 0. And I'll say p is equals to what? 2. You remember? For me to call this man 0 means that this man now, remove him and call him 0. 0 times this man will give me the answer 0. Therefore, I have this to make piece of data formula. I have to. I will say or again. Okay, maybe you are not the 0. This person, you are the 0. I have this minus 1 and is equals to what? 0. Therefore, p is equals to 1. So we have said that for these two things to multiply themselves and answer becomes 0, meaning that either this man is 0, which is p minus 2 is you are the 0, and I make piece of data formula. Oh no, you are not 0, you are the 0, and I have this. Then you remember, in the equation we are solving, you are the one that introduced p. I'm the one that introduced p. The p is not in my equation before. We introduced p by saying let 3 raised to the power x to be p in that equation. You remember you are the one that introduced it to make the equation to be simple for you to solve. Then you return it back. And I said, but I remember that I said that what p is equals to what 3 raised to the power what x. That means that what 3 raised to the power x is equals to what p. That's what I said before. That's what we pay. Therefore, I will not say that what 3 raised to the power x is equals to, what did I have the first one? Is equals to 1. P is 2 or 1. Are you understand that? So I said is equals to 1. Then I cannot say 3 raised to the power x. You remember, in indices, what do we use to what? To replace 1. I can use any term raised to the power 0 to replace what? 1 in indices, which one? I can use any term raised to the power 0 to represent what? 1 in the what? Indices. Therefore, I can say that this one is what? 3 raised to the power 0, which represents 1 as well. I will now say therefore that x is equals to what? 0. I've gotten the value of x, the first value of x to be 0. You remember that in a quadratic equation, you must have two what? Answer. Quadratic equation have what? 2 answers. I have gotten x to be 0. Also, I will say again, 3 x raised to the power 3 raised to the power x is equals to 2. 3 raised to the power x is equals to 2, because you remember that my p is equals to 1 or what? 2. That's what I got my p to be. 1 or 2. I got p to be 2 first and 1 as second. So 1 or 2. So I cannot say that 3 raised to the power x is equals to what? 2. And so do you. Can I make this to have the same base? No, I can't make it to have the same base. You remember? Can I make this to have the same base? No, this is base 3, this is base 2. I can't make it. Nothing I can do this to make it to have the same base so that I can say the power is equal. No. But here, I can make it to have the same base because this is 1. As this one is, I remember the law that if a term is raised to power 0 is equals to 1. And that's another way to represent 1. I have to make this, because I see this is base 3. I have to take base 3 raised to power 0, which represents this 1. And I equate the power to be equals to 1 to 0. That's how I get it. But here, I can't do what I need here. Because this is base 2, this is 2, this is base 3, this is 2. I can't make it to have the same base that will give me 2. So what would I do? I take log of both sides. I said log that of what? 3 raised to power x base 10 equals to log that 2 base 10. I'm taking log of both sides. Then, doing so, I have this log that of what? 3 base 10 equals to log that of what? 2 base 10. I cannot say that x is equals to log that 2 base 10 divided by log that 3 base 10. And doing so, we have substituted the log of what? 2 before, which we said 0, log of 2. Let's get it from my calculator. You can punch it in your calculator, punch log 2. Let's take the log, let's get the log 2 here. Have you punched it in your calculator? I'm looking at my calculator to know what I have in here. Log of 2. Log of 2, okay? I have log of 2 to be 0.3010, log of 3 to be 0.4771, and they will give me 0.6301. That means that what? X is equals to 0.6301, and I can say that x approximately equals to 0.6. Therefore, x is equals to 0 or 0.6. That's what they asked me to. That's my answer. There's the answer to that question. So solving that equation, he leads us to quadratic equation, and be able to learn how to what? Factorize equation. And that's where we're ending it today for this lesson 3. You look for lesson what? 4 for more clarification on this topic. As you watch the video, subscribe. Subscription is free. Subscription is free. Why you subscribe is for you to have prompt message. When you will post the lesson, you'll be able to get notification. Subscription is for you to notify whenever we post a video, and for you to be able to follow us as we post the video. It's free. Subscription is free. Also, for you to understand this lesson properly, you have to follow us from lesson 1 to the last lesson of each topic. That's the way of learning this properly and becoming a master of that particular topic. Also, I believe you will love this video. Share, comment. Also, you can ask questions through a WhatsApp number. You can ask questions by sending us the message through this WhatsApp number 08030937728. You can send a message. Maybe there's a question that you are confused about, or a question you have on this topic that is bothering you. You can send it through this WhatsApp number. This is a WhatsApp number. It's not a number to call. It's a number to send a WhatsApp. You send a WhatsApp number, you send it through this number, any confusion you have or what you want us to help you to treat on this YouTube. So you can communicate to us through this number, through WhatsApp, not calling. Thank you. Share this video to your friends. Thank you.